Hello and welcome to this lecture. I hope you enjoyed the previous video. In this video, we want to discuss about transistors. So let's go. A transistor is a semiconductor that regulates or controls current or voltage flow in addition to amplifying and generating this electrical signal and acting as a switch or gate for them. Transistors working as an amplifier and it can transform a small input current into a bigger output current. And also, it can work as a switch and it can be in one of two distinct states. It's on or off to control the flow of electronic signal through an electrical circuit. So, what type of transistor we have? Transistors are classified into different types based on their structure, functionality, and application. The two primary types of transistor, as you can see, are bipolar junction transistor or BJTs and field effect transistor or FETs. Bipolar junction transistor or BJTs are divided into NPN and PNP transistors. The NPN transistors consist of two N-type semiconductor materials separated by a thin layer of P-type. In contrast, the PNP transistors consist of two P-type semiconductor separated by a thin layer of N-type. So, the second one, field effect transistors or FETs. Field effect transistors are another major type of transistor, which are divided into junction gate field effect transistor or JFETs and metal oxide semiconductor field effect transistors or MOSFETs. Unlike BJTs, which are current controlled, FETs are voltage controlled devices. And so, what does this mean? This means that the output current in FETs is controlled by the input voltage. JFETs are used in modern electronics, while MOSFETs are used due to their high input impedance. So, NPN transistors. NPN transistor is a type of BJTs that is composed of two layers of N-type semiconductor material with a layer of P-type material sandwiched in between. The three layers of NPN transistor correspond to three regions: the base, emitter, and the collector. The emitter is the region on the one side that emits electrons or holes, and it's depending on the type of transistor. The base is the middle region, which is thin. And also, the collector is the region on the other side that collects discharge carriers from the base. The operation of an NPN transistor is based on the movement of electrons as the majority charge carriers. And when a small current is applied to the base emitter junction, it allows a larger current to flow from the collector to the emitter. This property of controlling a large output current with a small input current makes the NPN very useful device for amplification and switching. So, working principle of NPN transistor. The working principle of an NPN transistor is based on the control of current flow between the emitter and collector regions by varying the base current. The NPN transistor, as you can see, has three terminals: the emitter, the base, and the collector. The emitter is made of N-type material and the base is made of P-type material, and the collector is made of N-type material in NPN transistor. So when a small positive voltage is applied to the base emitter junction, the junction becomes forward bias and allowing electron to flow from the emitter to the base. Since the base region is the thin and lightly doped, only a small fraction of these electrons recombine with holes in the base. The majority of the electrons continue to flow through the base and reach the collector, which is reverse bias. So, PNP transistor. A PNP transistor is another type of BJTs which is essentially the mirror image of NPN transistor. It consists of two layers of P-type semiconductor material with a layer of N-type material sandwiched in between. The three layers of PNP transistor correspond to three regions, as same like NPN transistor: the emitter, the base, and the collector. The operation of PNP transistor is similar to that of an NPN transistor, but with the rules of the electron and holes reversed. When a small current is applied to base emitter junction, it allows a larger current to flow from the emitter to the collector. So, let me explain about a working principle of PNP transistors. The working principle of a PNP transistor, like its NPN, is NPN, and it's based on the control of current flow between the emitter and collector regions by varying the base current. However, the PNP transistor operates with holes as the majority charge carrier, which is opposite of the NPN transistor that operates with electron as the majority charge carriers. In a PNP transistor, when a small negative voltage is applied to the base emitter junction, the junction becomes forward bias. This allows holes to flow from the emitter, which is made of P-type material, to the base, which is made of N-type material. Since the base region is thin and lightly doped, only a small fraction of these holes recombine with electrons in the base. And the majority of the holes continue to flow through the base and reach the collector, which is reverse bias. And the reverse bias based collector junction creates an electric field that repels the holes away from the base and attract them toward the collector. As a result, uh, a large current flow from the emitter to the collector, which is controlled by the smaller base currents. So, I hope enjoy this part of my video. You can access to my contents from QR code below. Thank you.